All right, let's get started. Welcome to the session on design patterns in the light of Lambda expressions. My name is Subramaniam. We're going to talk about design patterns, but we're going to talk about how lambdas actually change patterns and how we use them. Well, I want to first start out by saying that I really hate design patterns. That was very motivating, wasn't it? Well, I'll tell you why I actually hate patterns. We often tend to really want to use patterns very quickly. And if you really think about it, how do we really figure out what patterns to actually use? Well, I want to say, if you really think about it, we all can agree that grandma makes the best pie. So you've been telling about grandma's pie to your friends, and your friends say, well, if grandma's pie is so good, why don't you make it? So you call grandma and say, Grandma, I've been talking about your pie all along. I want a recipe. I want to make it for my friends. So grandma gives you the recipe for the pie, and you write it down. And as you're writing down, grandma says, add 2 spoons of sugar. You say, wait, is it tablespoons or teaspoon? You ask for all these details. And then once all that is done, what do? You say, Grandma, let me go over this one more time, and what are the best practices? Well, after that, you make the pie, and how did it turn out to be? A disaster, wasn't it? The last time I tried this, I lost the spoon with it. So the point is, that didn't work at all. Then you finally meet Grandma and say, Grandma, that was a disaster. And Grandma says, let's make pie together. And you're watching Grandma make pie, and while Grandma is telling you stories, and then Grandma wants to add sugar, what does Grandma do? Grandma takes 2 spoons of sugar, measures it accurately, and puts it right? No. Grandma, while talking, takes some sugar and tosses it in. And you said, wait, what was that? Sugar? How much did you put? Enough? And that's when you realize Grandma never follows the recipe she gave you. Well, the guys who wrote the design patterns book are the grandmas and grandpas of industry. And the worst thing they ever did in their life is write the damn book. And now everybody thinks, right, we can actually do this, and wow, I can use patterns too. So it actually takes years of experience and making mistakes to learn use of patterns. So having said that, if we do decide to use a pattern, I often use a pattern as a way to communicate rather than as a design tool. And of course, it can be very easy to communicate and say, well, I'm using this factory method here. I'm using the abstract factory here or a decorator here. It can be a nice communication tool. So having said that, if we're going to use patterns, well, at least we can use patterns which are lighter weight than creating a monstrous set of patterns. So I want to talk about how actually patterns would change if we're going to be using these patterns with lambda expressions. Well, lambda expressions have changed the world in Java. They give us a lightweight design tool, and we can effectively use lambda expressions to write a lot of stuff where otherwise would have created a hierarchy of classes. So let's take a look at some examples of how this is going to really work. The first one I want to start out with is the iterator pattern. Let's start with the iterator pattern real quick. We all have used external iterators for a very long time. Let's say for a minute we have a list of numbers 1 to 10. I want to loop through and print the values. You say for int I equal to 0, I less than, well, numbers dot, you pause a second and think about what method to use here. Well, length if it's an array, size if it's a list, and then I plus plus. And then, of course, we could say output, in this case, numbers dot get the value of I. Well, that was a lot of ceremony. That's an external iterator, as we know. Or rather than doing all of that work, what I could have done is I could have simply said for int element in numbers, and then I could have simply said that. What a relief, that's a lot less code already. But these two collectively are called as external iterators, but rather than that, we can actually use an internal iterator and get our work done much more effectively. So we can say numbers dot for each, and we can simply, in this case, given an element, I want to simply output the element, and we can see that we do a lot less effort, less ceremony, and get the work done. Well, this ends up being an internal iterator. So what's the big difference between these two? Well, the very big difference is, in the case of an external iterator, we are pulling the element one at a time, whereas these iterators could be where we focus on what to do per element and not actually how to iterate it. So it gives us focus on what our job is rather than how to actually get this done. We could, of course, also use method references in this case. We could say system and then dot out, and then we can simply say print line, and this makes it much more easier to understand what the code is doing. doing makes the code a lot more expressive as well. So we can start programming with internal iterators. So that's one thing we're going to, first of all, do moving forward into Java is iterators just got such more lightweight, and we can use iterators like this, and we can build our own iterators as well, but we can start using lambdas quite effectively. But I want to quickly move to other patterns that we really want to focus on. Well, I want to talk about the strategy pattern. Well, strategy pattern is a pattern we all have used quite often, but I want to take a little example and play with the strategy and see how that actually begins to feel. Let's say for a minute you are working with a problem, and let's say for a minute that it's a very late Friday, and you know what happens late on Friday, right? Our mind kind of switches off. We got other things we want to go out and do. Well, imagine this is a very late Friday afternoon, and in fact, to make things worse, you got some really old friends you're going to meet and have a good party. So you're looking at your watch, you really want to go. Well, one of your colleagues comes to you and says, I want you to write a function that totals all values. This could be values that are numbers, prices, stock prices, weather data, whatever that could be, right? So they want you to total all these values. Well, how are you going to write it? So you're going to say total values, and then you're going to say numbers. Well, let's go ahead and write that little function for totaling the values. So I'm going to say public static, let's say total values. I'm going to use imperative style for a few minutes. I'll refactor it to functional style a little later. So in this case, I'm going to say integer values. We'll call it as values. And what am I going to do here? Well, first of all, let's say result is equal to 0. And I want to return the value of result when we are done with it. Well, but of course, I have to really compute the result. What am I going to do? Well, for, let's say, int element coming from values, and I'm going to simply say result is plus equal to element, and we can just quickly total the value. So that seems to work really well. And you look at your watch, you're eager to go, but unfortunately your colleague, the one who nags you all the time, comes to you and says, but I really need one more help from you. Could you please write also a method that will total not just all the values, but also total all the even values? So you ask your colleague, are you really interested in a function like this? And your colleague says, yep, that's exactly what I want. And you look at your watch one more time, and you're getting nervous because you really want to leave, but there's a bit of a good news. You quickly realize most of the coding is actually done. In fact, this code is doing almost everything you need to do. And then you look at this and you tell yourselves, there's got to be a reason why they created copy and paste, right? I mean, if nobody should ever use it, why would they create it, right? If it was so bad. So you quickly say total even values, and then you say, if e mod 2 is equal to 0, then total not otherwise. So in this case, this copy and pasting does bad things, as you can see right here. But OK, so in this case, of course, I'm going to go ahead and quickly run this code. And what does this really do? Well, I'm totaling all the even values, as you can see. That seems to have worked really well. Well, unfortunately, about time you're about to leave, your colleague walks in and says, but I need one more thing from you. I want you to total all the odd values as well. But you know one thing very clearly. Copying and pasting a code a third time is an act of criminal negligence. But it's a Friday night and nobody is looking. So you quickly refactor this and say total odd values, and you say if this is not equal to, then of course you got that code working. But the problem in this code is you duplicated the code 3 times, and that's just not acceptable. Well, while you're on your way, you stop by the nearest coffee shop because you're so guilty you start refactoring. But as fate may have it, some of your other friends are hanging around, and they come over to you and ask you what you're doing, and before you could close your laptop, they take a look at it, and they get to know your dark side. And of course, they don't return your phone calls anymore because who would want to hang out with people who do copying and pasting for a living anyways? So, you know how life really becomes miserable if that happens. Let's rewind this, get back to where we were a minute ago. So we have this code right here sitting in front of us, and we have this one function. Now your colleague comes to you and says, hey, could I please have a method that will total all the even values in addition to all these values? Well, yeah, you can have it, but before you do it, you decide to do one little refactoring before you add this function feature. So what refactoring are we going to do? Well, the very first thing we're going to do is we're going to look at this function here called total values. Right now, this function is called a normal function. So what in the world is a normal function? It's what we normally have been using. So a normal function can receive objects as parameters, and it can also return objects as a result as well. We're going to turn this function from a normal function to what is called a higher order function. So what is a higher order function? A higher order function may receive another function as a parameter. It can potentially return a function as a result as well. So the difference between a normal function and a higher order function is what you can pass to it or what you could potentially return from it. A higher order function receives a function as a parameter, and or it could return a function as a result as well, so you can begin to use that fairly quickly. Well, right now we have a higher normal function. I'm going to convert it to a higher order function, which is extremely simple. All I'm going to do is, given an element e, simply return a true. So notice how the total values, which was taking on just the numbers object a second ago, now is accepting two parameters, where the second parameter is actually a function that you're passing to this function. So what am I going to do now? I want to receive this function. Well, that's a lambda. But if you notice, this lambda is taking an object, but it's returning a Boolean. And there is a functional interface that matches that kind of signature. And that functional interface in Java 8 actually is called the predicate interface. So I'm going to bring in function.predicate right now. And all I'm going to do is add a second parameter where that becomes a predicate which takes an integer. And I'm going to call it as a selector, for lack of better words. And I'm going to simply say in this case, if the selector tests the value, and if it's happy with it, then accept it, otherwise reject it. Now, clearly the result did not change, which is why we call it refactoring. The code is doing the same thing, but we change the design of the code. And what did we do in this case? We are passing an extra parameter, where this parameter simply receives a value and returns a true. Now, of course, now you can get back to doing what your colleague wanted you to do, which is you can say, I'm going to compute only values for even number. So now we say mod 2 is equal to 0, and you can see that it's totaling the values for only even numbers. A few minutes later, your colleague comes in again and says, I want to write a function where I can total odd values. You tell your colleague, go back to your desk and do it yourself, because I've written it in a way that it's actually reusable, and we can easily use that value and pass in a different one. If you look at what we just did, we have taken a common piece of code right here in this, and the common piece of code is sitting right here nicely, but we extracted from the code just that little logic which decides whether a value should be totaled or not. Well, what concepts is that? Well, that's basically what a strategy is, except for one difference. In Java 7 and earlier, if you want to use a strategy pattern, you often organize a corporate design meeting. Here you just get it done. That's simple. So you can just get quietly some patterns implemented. Of course, we can rewrite this code to use more of a functional style here as well. So what I'm going to do is, rather than writing so much code, verbose code, all I'm going to do simply is to say return over here, and I'm going to say values.stream, and I'm going to simply call the filter function, and then pass the selector to the filter. After all, a filter is expecting a predicate, and a selector is a predicate, so I can just simply pass that to that. And then I can say in this case, well, I want to call a reduce function because all I'm doing is totaling, and I can say integer : sum, and I can perform a total operation of that value very easily. And you can see that in this case, we can rewrite this in a functional style rather than taking all that effort to write in imperative style, so the code becomes a lot easier. So here we use the iterator pattern along with the strategy pattern as well in this particular example. Of course, patterns very rarely live in isolation. We often mix them together, and that's basically what we saw here, is how we are able to bring that in as well. Of course, in this case, if you really want to use the sum method, which is another specialized reduce function, well, unfortunately, that wouldn't work directly here, but you can do something a little different to get that working. So if you do this, for example, that will be able to use a sum as well. The only thing you should never ask is, what what does that mean? Don't apply logic in these cases, okay? So basically, the sum works because it's working on an integer stream rather than on a stream, so a little goofy, but we had to do a little type casting here to get that working. In this particular case, it looks a little bit more odd than it should really do in other cases. So we saw how we can actually use lambdas to build the strategy pattern. So what's the lesson there? The lesson is, imagine you're doing a strategy pattern in Java 7 or earlier. What do you normally do in a strategy pattern? Well, you first create an interface, and then you create a hierarchy of classes that implement your interface. Then you have your class that wants to use the strategy, and this class will then depend on this interface, and then of course you would have classes implement that interface, and you would have built a hierarchy of classes. Well, to me, that's a lot of heavy weightedness you have to carry around. So in other words, moving into Java 8, where I would have had a library of classes, I'm now looking at library of functions rather than library of classes. So I can start readily using a set of functions. For example, let's look at one example here. Let's say for a minute, I don't want to use these functions explicitly here. Well, notice what I could do. I could have them in another class for all purposes, but I'm going to say Boolean, let's say, is even, and that takes a number here, and it's going to return number over here, mod 2 is equal to 0. Like I said, this could have been in another utility class for all practical purpose. In fact, why don't we do that just for the fun of it? So I'm going to say class util, and I'm going to put this into the utility class. Likewise, I can also create yet another function here, let's say is odd, and then, of course, in this case, I'm going to check if it is odd. So I've got this is even and is odd, but notice the beauty of this. I can simply go back here, and I can change this to util, and then I can say is even, and I can use that function right there. And likewise, I can change this to util is odd, and I can use that as well. So the point really is, rather than creating a hierarchy of classes to support strategic pattern, we can now create a library of functions and very readily use those functions using lambdas or using method references. That's a lot less code for us to write, a lot less code for us to maintain as well. So life becomes a lot better to work with it. And that's one of the things I really like about how lightweight this becomes with the lambda expressions. So we saw the strategy pattern. Let's now talk about the next pattern I want to talk about here, which is the decorator pattern. Now, I'm sure we all have read about decorator pattern, but I often feel that decorator pattern is one of the nice patterns that often really gets underused. But why don't we often use the decorator pattern? Well, one of the reasons why we don't use a decorator pattern often is because almost always when you look at an example of a decorator pattern, how does the example look like? New, for example, buffered input stream, and then new data input stream, and then new, by this time you're like, really? Right? So this is a really heavyweight, and you keep doing all these new, and you look at this pattern once and you decide, I will never ever use this. So this is a lot of work and a lot of objects being created, and we kind of lose interest along the way and say, that may be a really good pattern, but gosh, that looks really ugly. I'm not going to use it. So we tend to really underutilize decorator pattern, even though it's a really nice pattern for us to use. But before I talk about the decorator pattern, I want to talk about something else that will help us to implement the decorator pattern. Well, I talked about the predicate a few minutes ago. And you can do this with predicates, but I'm going to focus here on function for a minute. Well, one of the things you have in Java is a wonderful functional interface called the function. And I'm going to say integer, comma, integer, inc equals, given element, return element plus 1. Well, I want to use this increment, so I'm going to go ahead and say, do work, for example, pass a 5 and pass inc to it. Let's take a look at the do work function here. So I'm going to call the function over here. The function is going to be called as do work. So I'll say do work. and this is going to take a value as a parameter, but I'm going to pass a function which takes an integer and an integer. We'll call it func for a minute, and all I'm going to do is simply output. Let's go ahead and say the func.apply, and I'm going to pass this particular value passed in. Well, let's go ahead and try this. I'm going to pass that in. You can see that 5 plus 1 is 6. That definitely worked really well. But I'm also going to go back here and say, here is a function called doubleIt, and I'm going to simply take this value and I'm going to double. So in this case, I can call do work and 5 and double it, and clearly 5 times 2 is 10, and we can see the result is 10. But I want to do something a little different now. I want to increment and double. Well, how would I increment and double? Well, I could do something like this. I could say int temp is equal to inc.apply, and then I would say 5 over here, and that gives me an increment of 5 with a value of 1, so that's going to be a 6. Then I could output, in this case, a doubleIt.apply, and then I could pass a temp to it. Notice, of course, 5 plus 1 is 6, 6 times 2 is 12, and the result is actually 12. But what did I do here? I did something really nasty. What is that called? We normally call this a garbage variable. In fact, we hate those variables so much, we call it like temp. We never give it any respectable name after all, right? And that's a sign that shouldn't really exist, and it's only there because we couldn't really get rid of it. So what if we can actually get rid of those kinds of functions? Well, thankfully, we don't need those garbage variables. So I'm going to call doWork, 5, but notice this time I'm going to say inc and then, and I'm going to just simply say doubleIt, and you can see how nicely we can combine these functions together to do some really nice sequence of operations. So you can take these two functions and you can say, I got function 1 and I got function 2, but I'm going to ask function 1 to hold the hands of function 2, and when you pass the object to a function 1, it does its work and returns that to the function 2 and says, here you go, and the function 2 takes the result given, does its work, and returns your result. So you can do a nice chaining of these objects very easily. So functions already provide this, and so you can nicely chain them together. Well, now we can start employing some of these features very effectively for a greater good. So let's take a look at an example of what I can do to maximize the benefit of these kinds of operations. Likewise, you can also use this in predicates as well. You can combine predicates using and or and those good things. You can do that as well. To understand what we can do with this, I'm going to take a class called a camera class. So here's a camera class, and my camera class is going to have one function, and the function I'm going to have is called color, a bit scary, but I'm going to say import java.awt. Let's say star. And of course, in this case, I got a color on my hand. I got a snap, which takes a color, and I'll call it as input. And all I'm going to do is simply return the input given to me. Let's start with that for a minute. So now I'm going to go back here and write a little function. And the function I'm going to write here is going to be, let's call it as print, snap. And I'm going to pass a camera to it. We'll say camera. And what am I going to do within this? Well, the first thing I'm going to do here is I'm going to first of all output camera.let's say snap. And I'm going to pass a little color to it. New, let's say color. And I'm going to pass 125, 125, 125 as the value to it. Let's go ahead and give this a try real quick. So I'm going to call the print snap, and I'm going to say new camera and pass a camera to it, and then ask it to do the work. So when I run this little code, what does this do? It's supposed to run through and print the snap for us and give us this output. And I want to see the output of this when this actually runs. Well, that seems to be really, oh, there you go. So eventually it showed up. So I'm going to run this and see the output of this particular call and being displayed right there. So that's great. That's a first step. But what I really want to do, looks like it's giving a little trouble, so I'm going to run this on the command prompt so that I can just directly run it. So give me a second to get to where I want to get to. So I want to just quickly run through this and see the output. So let's go ahead and say, I want to run this little code. So I'm going to say, go ahead and compile and run it. And in this case, of course, I can see that the result of this particular call should really output the color given to it. So you can see the color just comes out. Great. Now what am I going to do? Well, I want to really do some, color manipulation, and I want to be varying some of the things. So how am I going to able to do that? Well, let's first of all create a constructor here. We'll say camera right here is the constructor I'm going to create. And what am I going to do in this constructor? Well, I could call a function called set, let's call it filters, and I'm going to call a function called set filters. So what does this set filters do? Set filters is going to set some colors for me. And what is this set filters function, what does that look like? Well, set filters says I'm going to take a function. In this case, given a color and returning a color, we'll call it filters. Well, this is going to be filters, but I'm going to pass a var arg to it. And so I'm going to receive filters as a parameter. We'll come back and see how we're going to write this in just a few minutes. But I'm going to start with no filters to begin with. I don't care about any filters. So this works really well because you don't have to pass any colors after all, because the var arg will be happy to receive it. So in this case, I'm going to say private function, let's say color, comma, color, and I'll call it filter. And in this case, I'm going to simply say filter is equal to, well, to begin with, I want a filter that does really nothing. So I'm going to say, given a color, simply return the color. That is my default filter to begin with. So notice this is a lambda, and this lambda says, whatever you give me, I'll simply return it back to you. So that's basically what the filter is right now. I'm not even using the filters yet. So what am I going to do in the snap? I'm going to simply say filter dot apply and then simply pass the input to it. Let's make sure this part of the code works so far before we go any further. So I'm going to go ahead and run this little code and see what the code does. Oh, wait a minute. It is giving me a warning. Oh, it actually gives me 2 warnings. But as Java programmers, we know exactly how to take care of those warnings really well. So we can take care of that. So suppress warnings. Isn't that beautiful? Unchecked. So you can take care of that and make sure that never ever comes back alive. So you can try that. Oh, wait a minute, I made an error saying that. So suppress warnings. Okay, that's good. And then make sure that's working. And of course, that seems to have fixed the problem really well. Awesome. So this is great to really teach junior developers, right? Here's how you deal with warnings. Okay, so we have that particular code working. That's great. Now what am I going to do? Well, now that I have this working, notice what this is doing. It's simply returning what was given to it. But what about the filters? I still want to use the filters, isn't it? Well, let's go ahead and pass this through the chain. I'm going to pass this to the constructor itself, and then I'm going to bring in as filters one more time here. So that's basically filters being passed in. Again, I didn't do a whole lot. Let's make sure that part is still working. Well, obviously in this case, new camera is not, more warnings. This is lovely, but we know exactly how to take care of that also. So let's go ahead and do that. So now that that's taken care, no more warnings, well, the code is still working. Great. Now I want to really pass some data, but before we do that, let's see where the declaration actually comes in. Well, notice this is filters. But you know in Java what this is? This is an array of objects. That's what you're dealing with. Well, you know that if you have a list on your hand, you can say list.stream to get a stream. But we don't have a list on our hand. We have an array. So what I'm going to do here is I'm going to first of all say a stream.off filters. Well, let's go ahead and bring in the stream to begin with. So I'm going to say here is my stream class coming in. So I'm going to say given this particular stream of filters, now what am I going to do? Well, I want to take a bunch of streams, but I want to combine them into one single value. Well, if you think about what streams do, streams offer functions like filter map, but there's one other really interesting function called the reduce function. So what does a reduce function do? Well, reduce function says given a collection of values, I can go through and create one single value from a collection of values. It's a reduce operation. So all I want here is a reduce operation. So what what I'm going to do here is simply say dot reduce. And reduce takes two parameters. The first parameter, the reduce often takes is an initial value. And the second parameter it takes is a lambda that is going to know how to combine these values together. Well, you know what my initial value is? My initial value is, given a color, return a color back to me. And that's what we used a few minutes ago as the default value if nothing was available. So I'm going to start with that as my initial value. But what about the lambda? Well, the lambda says, in this case, the lambda says, given the filters, so we can call this as the accumulation or carrying over, we'll say the filters in here, so filters, and then I'm going to say a filter, we'll call it a filter. So given the filters and the filter, what should I do? Well, I'm going to say the filters dot, and I'm going to say and then, and we will simply add a filter to it. So we can see how I'm able to combine these filters together to reduce this even further. So if I go back and try this little code, make sure that's still working, well, that part is still working. But of course, this code doesn't make us really feel good. We want this to be a lot more concise than this. But the good news is we can do quite a bit of refactoring really nicely. Well, folks will tell you that this actually is called an identity function. So rather than doing color is color, I'm going to say function.identity. That's what I'm going to call to begin with. So that takes care of the color to color function. But what about this one? Well, if you closely look at this, there is a bit of a good news in here. Notice we are not doing anything with the data except we are just receiving the parameter and we are quietly passing it over. Well, you know that if a lambda is simply receiving parameters and passing it without doing any work, you can then replace those lambdas with method references. So that's pretty awesome. We can do that. So I'm going to replace this code right here that you see with simply function in here. So function and then, and that would take care of that really nicely. I don't have to write that clumsy code at this point. So that reduces the code really nicely, as you can see, into just a little piece of code. Let's make sure that's still working. That seems to be working just fine. Well, okay, great. Now let's go ahead and do actual use of this decoration. Now that we have the code built up nicely, let's try something else. I'm going to call print snap and do camera, but in this case, I want to say color, and I'm going to say brighter, so brighter, and I'm going to enhance the color to a brighter color, as you can see. Well, now if I go back and run the code, you can see in the second case, it is no longer 125. The color actually is brighter. It's 178. So we applied a little transformation function here when we called it. Likewise, we can also do this one more time, but now we're going to say darker rather than brighter. And you can see in this particular case, when I run this code again, you can see that in this case, the color is less than 125. That made it darker. But hey, where in the world is decoration after all? Well, I can now do multiple of these. And don't ask me why I would do this, but I can take this and say, right here, I can add this to be brighter, and then comma, color, and I can say darker as well. And now you can see that in the last example, I'm taking 125 and making it brighter and lowering it back. Well, of course, it says, are you kidding me? And it loses some little signal there. Okay, but it's kind of working, right? So you took it up and you brought it down. There's always wonderful rounding going on somewhere. So you can see how we are connecting multiple of these together. Well, take a look at this code. It's not scary like the new and new and new. This nicely provides a chain of things for you to provide. So imagine you have an application where you got bunch of transformations or algorithms or logic to perform. You can pretty much pick whichever you want to apply, and you can combine them together very nicely. So the code looks so concise in the case where you are actually using the decoration. And then, of course, if you notice, that was very concise as well in terms of how you really form performed the decoration or the chaining of the filters as well, that's very, very easy to write also. So only a few lines of code we had to write employing a nice feature in Java 8, which is the ability to combine functions together. And by using that feature, you can see how we were able to nicely implement a decorator without that clumsiness and the clutter and the noise that we used to. So I think we will probably be able to use decorators much more moving into Java 8 thanks to this particular approach. Well, I want to talk about two other patterns, but quickly though, a word of caution, both the patterns are going to look a lot like each other. In structure, they're going to look very similar, but the intention is quite different, which is not unusual because if you look at design patterns, this is pretty common in design patterns. In design patterns, it's quite often that two, if not three different patterns may actually look almost the same in structure. In fact, there are patterns that have identical structure. For example, a decorator pattern often has a very similar structure to the composite pattern, even though the intention of using them is quite different. So the two patterns I'm going to show you here are going to look a lot like each other, but the intention is very different. But before I take the second pattern or the next pattern, I want to create a slightly different example and work through it, and then draw into that particular pattern that I wanted to use here. So what am I going to do here? Well, I'm going to create a little class for us to play with, and the class that I'm going to create over here is going to be a class called mailer. So I'm going to get rid of things we don't need. So let's go to the class called mailer. So I have a class called mailer, and a mailer is going to have a few interesting functions. But I'm going to start out by first writing a function, a static function called print. This is purely a convenience function for myself so that I don't have to duplicate so much code. So I've got a little print function. But the real functions I'm interested in are the following. I'm going to write a function called from. And the from function says string, let's say, address. And in this case, I'm going to simply call the print and send the word from to it. So that way I can see that it's actually printing it. And I got another function called to, and I'm going to simply say to. I've got a function here called subject. That's going to take a line as an argument, and I'm going to simply say subject. And then I have a function called, let's call it as body. I've got a message, and all I'm going to do is say body here. And finally, a function called the send, and all that the send function is going to do is simply say sending. Well, the body of the functions are really stupid, but our intention here is not the body of the function, but we are really interested in the interface of this class. So I've got a little class called mailer that I've created. But of course, I want to reuse this mailer in my code. So how am I going to use mailer? So mailer, I'm going to say mailer equals new mailer. So we created a mailer object. Mailer.from, I'm going to say where this email is coming from. Well, that email is coming from builder@agiledeveloper.com. And you can imagine who this mail is going to go to. Well, that email, as it does every single morning, goes over to my email address. And what is the content of this email? My builder likes to send this email very often to me. It normally tells me, your code sucks. And it doesn't usually stop there. It also goes to tell me how it sucks today. So it tells me a little bit of a reason as well. Here you go. And so that's going to be, and finally, mailer.send. Well, if you look at this little code, this code is really a configuration to set up a kind of a mail that I want to send out. Well, question, anybody who has written code like this before? A few hands, okay, more hands, more people being courageous to raise the hand. Yeah, others, I know you're feeling, you don't want to never admit to this in public. Well, this is called Java programming, right? We all have done this. But if you look at this code, there are two problems, at least two problems with this code. The first problem is, look at the noise in this code. You keep saying mailer, 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 mailer. If you do this to somebody next to you, they may strangle you, right? Because it becomes annoying when you say this so many times. The second problem is, can I reuse the mailer on line number 22, or should I not reuse the mailer? Well, you know there are two answers. The answer is yes, you can reuse, or no, you shouldn't. But the point is, how do you know? Well, what if you reuse and you shouldn't? Well, that's called a bug. Hey, what if you should reuse and you don't? That's called inefficiency. So both of those are not good. So how do you know whether you can reuse it or not? Well, here's an idea. I don't know whether I can reuse it or not. And you may suggest, why don't you go read the documentation? How did that go for you the last time you did try to read a documentation? Well, the other day I was looking at a piece of code, and honestly, I have to admit, the function name was pass-through. And honestly, I did not know what pass-through meant. So I went to the documentation, and the documentation said, this method allows you to pass through. Well, thank you very much, right? Those are not called Java dog. Those are called insult the programmer. And I still don't know what pass-through means, right? So the point really is, documents don't help us. Well, here's another idea. Why don't you download the source code and read it? Well, you know what happens when you download the source code? The minute you do it, you begin to curse, right? And that is really hard. You know, my wife often tells me, you're such a nice person, except when you sit in front of a computer and look at the code, right? And that kind of happens. We transform to another being when we look at a code, and all the foul words keep coming out of our mouth. And that's how we're feeling with code always. In fact, this is even worse. The other day I saw somebody who was endlessly cursing at a piece of code until he realized he was the original author and didn't remember it, right? So that happens as well. So looking at the code is not a good answer either. So the point is, wouldn't it be nice if there is one way to do this and there's no other way actually to do this? The right way is the only way to do it. Well, that would be really nice. But we have two problems on our hand. Let's address the first problem. I want to remove the noise in the code. So how do I remove the noise in the code? I'm going to use what's called a cascade method pattern. So cascade method pattern is going to be a pattern where we're going to nicely cascade through the methods and apply that particular pattern. That's the very first thing we're going to do here. So what I'm going to do is, I'm going to first of all go to this code. I'm going to take each of these functions, I'm going to change these functions to, rather than returning a void, I'm going to return a mailer from these functions. So each of these functions are returning mailer, but of course that's not enough, because each of these functions need also to return a value of this as well at the very end. So we refactored it to return the this value. Now, of course, I've made that little change. Now what am I going to do? I go back to this piece of code and I say, I'm going to take away this mailer from here, and I'm going to go ahead and take away that mailer, and I'm going to remove all that semicolons from the very end. And so we are using the so-called cascade method pattern. Some people fondly like to call this as a train wreck pattern as well. You can use either a train wreck or a cascade, depending on what you are interested in looking at. So in this case, you can see how we removed that noise in the code by simply going through and taking the result of one method and passing on. Well, sometimes you may call this as a builder pattern. That's perfectly fine as well. So you can see how this is going to cascade through. Well, now that we removed the noise, we have still the second problem to deal with, which is, what do you do about in the object? Can you use the object at the very end of it? Well, clearly in this case, could have saved the object and reused it, and is that the intention? Well, to fix that, what I'm going to do here is, I'm going to first of all go back and say that the send method is a static method. So now that I made the send method a static method, I'm not going to call this method on the object anymore. So what am I going to do? I'm going to remove the method send from here, and I'm going to replace this with a mailer, so mailer.send as a function. Well, now that send is a static method, I'm calling it on the class, but then how would I go about really using it? Well, in here, I'm going to say mailer. Well, notice the difference here. Well, usually we pass the objects to functions. Well, now we're going to pass a function to a function, but the function in turn calls our function and returns the data. So you can see this two-way communication, which is really cool. You pass a function, and through that function, they pass a data back to you. So there's a nice way to go back and forth with the data. So in this case, I am passing the highlighted code here is a function that I'm passing to send. In other words, I'm going to make the send method a higher order function. Because I'm passing a function to send is going to give me an object which I can hold on and use it in this function. So what am I going to do within here? All I'm going to do within here is, now that I have received a mailer, I'm going to say mailer dot and do all that work right there up to the very end. So notice now how we change the code to say, I'm going to receive this mailer and going to use that mailer that's been given to me. Well, but of course, for this to work, I need to do some work on the send method itself. Well, I already brought the function package, so I'm going to say consumer right here. So consumer, and this is going to become a mailer, and I will say block, and within here I'll say mailer equals new mailer, and block dot accept, and I will send the mailer over to it. So now if you notice what this code is going to do, we can nicely exercise this code, and you can see the code actually still is working. So what did we do? What we did in this case is, we called the send method and we sent the lambda to it. The send method creates an object and gives the object back to us in the lambda. And then in the lambda, we use that object and then we return. Now comes the question, hey, on line number 26, can I reuse the mailer object? And the answer is, what mailer object are you talking about, right? Because there is no mailer object on our hand, because the context of the mailer object is within the lambda. And the minute you return from the lambda, you go back to the send method, and the send method keeps the object internally. You don't have access to the mailer object outside. So that becomes a nice way to bring in fluency, but you're also able to decide whether to reuse the object or not. Hey, should I reuse the object or not? And the short answer is, that's none of your business. Simply go ahead and use the object and go home, be happy. Let the author of the class decide it. If the author of the class doesn't want you to reuse the object, they can create a new object every time. If they want you to reuse an object, they can store it away in proper collection and give it to you, and they can manage it. And if you really think about it, if a resource is precious, whose job is it to manage? Of course, the author of the class's job. It shouldn't be a burden on me as a programmer using that object. So this puts the burden on where it rightly belongs, and good separation of concern as well. So that gives us an idea about how to really make use of this particular pattern using lambdas again. Well, the next pattern I'm going to show you is one of my most favorite patterns. We're going to use something very similar to what we did, but this pattern has been around for a very, very long time. I actually read about this pattern in Ken Beck's book called Small Talk Best Practices. So this pattern has been around for a good 30 years or so, but now we can actually use it because finally Java has lambda expressions. We can use these patterns. So this pattern actually I like quite a bit because it gives us a nice way to do some operations, and there are so many uses of this pattern. I'll give you a few use cases. But before I talk about the use of this pattern, I'm going to bring up a slightly different example so we can actually learn how to benefit from this pattern. So let's say we have a class called resource, and the class resource has a constructor right here, and I'm going to simply say in the constructor output, let's say created. I also have a function right here. The function is called op1, and all I'm going to do is simply output op1. I also have another function here called op2, and I'll just simply say op2. And finally, I have a function here which is public void finalize. And imagine I want to clean up right here. And imagine this is a very expensive resource. So one of the things that Java did really poorly, in my opinion, is bring garbage collection and resource management into the same fold. These two are completely different from one another. You can have automatic garbage collection, but managing resources is a completely different thing. And trying to say that the resource will be cleaned up when the memory is cleaned up is not a good idea, but we have endured this pain for a while. Now, if you go back to this code, I'm going to say resource, let's say resource equals new resource, and I'm going to say resource.op1 and resource.op2, and then of course when I run this code, you can see it created the resource. Hey, but wait a minute, it did not clean it up. Why? Because garbage collection in Java is kind of like garbage collection in my neighborhood. Just because I put the trash out doesn't mean anything, right? So the point is, it says, yeah, I've got a lot of memory. I don't have to do this. My first fear is, did I misspell finalize? Oh, no, I did not misspell finalize. Actually, This happened on a project. A company called me, and the boss called me and said, hey, we got a request for you. Can you come and work with us? We want you to do code reviews. We want you to look at all the code and help us improve the code quality. But while you're doing code review, maybe you can help find and fix a problem we've been having for several months now. I said, tell me about this problem. He said, go talk to the programmers, they will tell you. And I went to the programmers and kept asking, what's the problem? And nobody could really help me, really tell me what the problem is, until one programmer just nailed it. That programmer said, our application works fine most of the time. I said, that's great. Can you tell me when it doesn't work? He said, of course. It doesn't work between 7:15 and 9 in the morning. I said, oh my gosh, every day. He said, no, only Monday through Friday, right? I was like, wow. So Saturday and Sunday, not a problem. So this made me really worry. Why would it fail during work days but not on weekends? Well, it was a company with 100,000 employees. It turned out so that you know what happens between 7:15 and 9 in the morning? People come to work. Whether they want it or not, they log on and get to the portal application. These guys were developing a portal application. When I started doing the code review, here's what I found out. I found out that in the constructor, they were opening a database connection. In the finalize method, they were calling a close on it. And the minute I saw this, I'm like, uh-oh, wait a minute. That wouldn't be fun at all because you guys have a lot of memory. The garbage collector is not going to kick in, which means you got all these connections open and new objects are going to ask for a new connection without closing the old one. That's not going to be fun. And when I told this, one of the developers started monitoring the database connections and we could see that inch up and get up there. And of course, all these constructor calls were failing, but not enough exception handling code was propagating that. So the minute I got a wind of it, I made only one change. All I did was I changed this function to close. And the minute I changed it to close, I went to the code where they are using this function, and I asked them to go ahead and, of course, in a similar example there, and I said, go try this now. And then they try it. Of course, in this case, when I call the close, the cleanup happens. In their production application, what happened was the developer said, oh, yeah, now the connection is pretty stable, and we are not getting errors anymore. It was kind of funny to watch this in the afternoon. The boss came back from lunch, as bosses normally are. He was fairly curious, and he came in and said, how are things? And one of the team members said, we got some good news. Remember the problem we've been having for several months? That's gone. He said, that's awesome. What did you guys do? And one of the developers said, well, Venkat asked us to add this one line of code, and we added, and the problem is gone. He said, really, what else did he do? Well, that's all he did. He just added one line. And then there was a little pause, and after that I heard him ask, if you only added one line of code, do we still need to pay him? Well, sure, right? So the point really is, we have to absolutely do the right things. Well, in this case, of course, there are two problems in this code. The first problem in this code, is there a problem in this code, by the way? Easy to forget close, right? That's the first problem. But the second problem, exception, right? So what if there is an exception in the code, and of course, close will never get called? Let's fix the exception problem now. Well, to fix the exception problem, I'm going to say try over here, move this into the op over here, and I would say finally, and within the finally block, I'm going to call the close method. Well, good news, even if there is an exception, this will go away. Now we have two problems. The first problem is it's verbose. It's more stuff you have to write. Second problem, this is not easy to forget. It is easy to forget plus plus now. Because it's not only easy to forget close, now it's easy to forget try, finally, and close. What are the chances? Well, let's again fix the second problem. Can we reduce the verbosity? Well, I got some good news for you. Java 7 has a feature to reduce this. So Java 7 has a feature called ARM, which stands for Automatic Resource Management. And what this feature does is it says you don't ever have to use finally anymore. So I get rid of the word finally. And instead of putting the word finally, what I'm going to do is I'm going to say, well, let's use a try with resource. So I'm going to say in this case, move this code from here up to the try block directly. Well, unfortunately, though, this doesn't work at this time. Why not? Because I got to go to the resource and say implements, and I'm going to say auto closable. So in this case, I'm going to say auto-closable. And the minute you put auto-closable, it's simply a tagging interface and needs to have a public close method. And Java says, oh, you put auto-closable there, I will take care of this for you. So now if you notice when I run this, good news, it called close automatically. So I could say not so verbose. So that's definitely a great news so far. Who would want to write finally after all if we don't really have to write it? Well, that's great. We're using the ARM, so we should be happy about it. But remember, we had two problems a minute ago, right? The one problem was it's verbose. The other problem is it's easy to forget. We removed the verbosity quite a bit. But what about forgetfulness? Well, I'm a very forgetful guy, so it's quite possible that I may not put the try at all. And what I may end up doing is simply call resource without the try like this. But here comes the question. Remember how we did put auto-closable, so the compiler knows that there is auto-closable. So my question to you is, will the compiler give you an error, or will the compiler give you a warning at least to say, hey, dude, you need to handle this? What do you think? The answer is no. But of course, you know this extremely well when I started this part, because you know deep in your heart never ever to trust a feature with the word management in its name. So that doesn't work after all, right? So clearly in this case, when you did this, you can see that didn't really work. Well, that sucks. Okay, great. So forget about this. Wouldn't it be nice? So just like everything else, eventually we're on our own when you depend on management, right? Okay, so what do you do now? Well, of course, I want to really make this work the right way. So we're back to square one we started out with. What do? Well, the first thing is, of course, you could in good faith say resource.close and call the close, all those good stuff, but let's fix it. The very first thing I'm going to do is to change the close into a private method. Aha, I made it private. What's going to happen? Well, the developer comes along, runs the code. It says, sorry, you cannot compile it. You cannot call close. And the developer says, okay, no worries. Well, that didn't really solve the problem yet. Okay, that's the first step. The next thing I'm going to do is make the constructor private as well. Now the developer is going to come back and say, what gives? I can create an object to this class. How do I use it? Well, welcome to the right way of using this object. So we're going to go back to this code, and we're going to write a function. And the function I'm going to write is going to be a static void use function. And this function says, I'm going to take a consumer of resource as a parameter. And within this function, I'm going to say try and finally. Well, remember, as an author of this class, I know exactly how to do this and why to do this. And then, of course, in this case, I'm going to say resource.close and call the close. Where is the resource, though? Well, I'm going to create the resource equals new resource. So I created the resource right here. And then I'm going to basically say here block.accept and then pass the resource to it. Now, in general, you may have constructor parameters, but that's no big deal because you can pass the constructor parameter as a parameter to the use method, and then you can have that passed in here as well, so we don't have to really worry about that detail. So as a result, you can see in this case, we got the use method and we got the consumer. We created the resource, passed it on to the block, and said, use it, please. And when you're done, come and call the close method. Now, if you notice what I'm going to do here on this side, I'm going to say resource.use, and I got a resource on my hand. And what am I going to do now? Well, all I'm going to do here is simply say resource.op1, and I'm going to just move this down into the code right there. And in this case, of course, I'm going to simply call those two methods. And of course, I can simply make this change here as well. And I'm going to return a resource. That way I can just tag along, and I don't have to really do what I was doing there with multiple calls. So in this case, of course, I have these two functions. And you can see in this case, we have the op1 and op2 we are calling. So let's take a look at the complete code for this. So this is called an executable execute around method pattern. But why? Because in the bottom you can see line 23 and 24 is what you really want to execute. But around that method, before the method you want to do a pre-op, and after the method you want to do a post-op. For that reason, sometimes this is also called as a loan pattern, because this is as if the object is on loan to you, and it doesn't matter what you do with the object, but they do something before they give it on loan and after you return it. Kind of like rental car companies. If you go to rent a car, assuming it's a good rental car company, they clean the car and give it to you. When you return the car, generally, they check for damages. More so for me than others, but they check for damages. So the point really is, we have this loan, but before a loan is given, something happens. After a loan is given, something happens. And so this is also called as a loan pattern. I've used this actually quite effectively on projects where I have to deal with a certain logic repeatedly, but I have boilerplated code in this application, and I take all the boilerplate code and roll it into this function, and anything in the middle, like a sandwich, that I want to do separately, I would use this pattern to do this. So for example, I would say transaction.runInTransaction, give the transaction parameters. It will give me a transactional object. After creating the transaction, I will do my stuff and return, and the code will now check for any errors and log, and then of course return the roll back, or if everything was good, it would commit and do any optional logging that's needed. So we can use this in so many places. This is a great way for us to use this in projects where there are policies we have to maintain in code, and that can be nicely kept away, tucked away in the use-like method, which can enforce those policies and yet give you control, yield to you, and say, go do whatever you have to do. So this becomes a very powerful way to write the code with this kind of feature. This is one of my most favorite patterns that I've used actually, where lambdas can shine really well. You probably have seen this also in other languages where you open a file, but you never have to close it. Because when you open a file, they give you a file handle, but when you return, they will do the close for you, because they gave you a handle to the file in a consumer like this, so you don't have to really waste your time and effort or forget to manage resources. They can take care of it for you. So what I showed you here is how we can actually effectively use Lambda expressions to rethink about design patterns we've been using for a while. With Lambda expressions, design patterns become a lot more lightweight. There are a few patterns that we have used in Java that become a lot less painful to use. And there are some patterns that we have never used in Java before, or not as effectively, and those begin to shine as well, thanks to Lambda expressions. I hope you found this very useful. Thank you.